We talked about independent events, right?
Sorry, sir.
We talked about independent events or not? Like independent events, dependent events.
No, we talked about exclusive and all, not independent.
Okay, mutual exclusive we talked. Yeah, independent events we talked.
Oh, okay, okay. Sorry, sir.
So occurrence of one event is not dependent on occurrence of another event, right? So based on that, we have some problems. Solve it. Do you have any workbook for Jam or
Mm,
at least previous year questions book?
no, sir.
Okay, you should. I'll try to send. Okay, you should be doing simultaneously as I complete the respective topic. Should be taking the previous year questions of the respective topic and it should be solving. I'll try to arrange it. Okay.
Okay.
So the question on the independent events it is. So even if you don't know, if I don't tell which topic it is dependent on, you should be able to find out on which topic it is dependent if any question is given. Okay, because they will not be giving any topic name before the question. Like it is from conditional probability, it is from total probability, it is from different events. They will not be telling. You should be able to judge it. Okay, take this problem. Yeah, try to solve this. For that, the formula is for independent events, A intersection B is equal to probability of A into probability of B. This is the formula you should be using.
No, sir.
Why not?
Because probability of A intersection is not equal to probability of A and probability of B.
Okay. So let's check this out. Okay. So so first event is the sum of the results obtained is an even number, right? when we get a even number by adding what two numbers, either we should add two even numbers or we should add two odd numbers. In these cases only we'll get a even number as the output, correct?
Yes.
If the mixture of is there, we'll get an odd number. You should be knowing this. So let's write the, so sample space is having 6 into 6, 36 items. Is it correct?
Yes.
If I roll a dice twice. So the event A will be having some set of things like 1 comma 1, all 1 comma 3, 1 comma 5, then 2 comma 2, 2 comma 4, 2 comma 6, 3 comma 1, like this. For each it is 3, right? So it is uh, 6 into 3, 18 you'll get. Okay, for each number. So for each number like 1, I'm getting 3 odd numbers. For even numbers, I'm getting 3 even numbers. So like that, you'll get for each number 6 numbers, you'll get 3 possibilities. That is total 18 possibilities, correct?
Yes, sir.
So probability of A is equal to 18 by 36. That is 1 by 2. Now, probability of B. Sorry, B set. What is the B event? That is the result of the second roll is an even number. So here we are not considering what is the first one. The total might be even or odd. We don't consider care. So this they are saying the result from the second roll is even number. So something like this: 1 comma 2, 1 comma 4, 1 comma 6. Then 2 comma 2, 2 comma 4, 2 comma 6. How much we'll be having like this? It is also 18. That is P of B is equal to 18 by 36, 1 by 2. Because for each number you'll get three options. That is 6 into 3 is 18. Okay. So here common things. A intersection B is how much? It is the even number set. Like for 2, 4, 6, you'll get 3 times, right? That will be in both of the set. That is 3 into 3, 9 is the common thing. Then probability of A intersection B is 9 by 36, that is 1 by 4. So that is equal to P of A into P of B. So hence it is an independent event. So you are getting confused with mutually exclusive and independent events.
No, 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 sir. I got 9 by 36, but I didn't check it was 1 by 4.
So if you check whether P of A intersection B is equal to P of A into P of B or not, then it is independent or not independent. Okay.
Okay.
Okay, fine. That's it about the basics of probability. We'll be now seeing random variable. Okay. Now so this was mostly about discrete uh, probability. We'll be now talking more about continuous probability. Okay. So let's talk about random variable now. Important topic again. So random variable. So a random variable is a numerical quantity. Okay, whose value is dependent on the outcomes of different random phenomena, like different random experiment it might be. So it is multiple experiments are included. Sorry, multiple events are included in one random variable. Like that, you can consider of. Okay, a random variable will consist of multiple events, a set of events. Then it is becomes a random variable. So variable means it can have multiple values, right? Variable means the value is not fixed. So the multiple values possible is called as random experiments. So a random variable can be having random experiments. So it is a set of random experiment like that you can consider. Okay. Now let's take the definition. A random variable is a numerical quantity whose value depends on the outcome of random phenomenon. There are two types of random variables. Here again there are two types. One is discrete and continuous. Mostly we'll be talking about continuous here. So one is discrete. Discrete means what? And continuous means what? What is the difference between discrete and continuous? Yeah, Nanya. What is the difference?
Discrete is like countable.
Yeah, countable sample space and continuous is uh, infinite number of variables, right? Now, okay, see, second. Okay, discrete random variable takes countable values like number of heads in three coin toss. So here, why we are talking about random variable is so we can write the sample space for one head, one toss, two toss. We can write for as the number increases, like 4, 5. We can't write the sample space, correct? But we can understand the what is the trend in the sample space, how the sample space will be. We can justify, but uh, but we can't determine the actual like we can't sit and write actual sample space. It will take so much time, right? That's why we take it as a random variable. The variable means it can be 2 toss, 3 toss, any number of n toss. So for n toss, how much the trend will be there, we'll just calculate it. Okay, the trend will be same. It is like head tail, then the cross product between head tail. So head tail you have. Then second time it will be a cross product between these two. Then third time it is the cross product between three things, right? Like that, it grows the trend. Is it correct?
Yes, sir.
Yeah. So that trend we are taking care and we are trying to solve it. Okay. And second is continuous random variable. As we know, that takes infinite possibilities. Okay. Now we have something like probability distribution. Okay. So the probability distribution is like trying to create a table. Okay, probability distribution mostly a table kind of thing, where we have the result for each outcomes. So if you are creating a table of each outcomes, then it becomes a probability distribution, and we can plot it on the graph like that. So let's see this. For example, if I have a sample space like coin tossed two times, so the sample space will be equal to head head, head tail, tail head, tail tail. So the probability distribution is something like this. So it will be having number of heads, and so let me consider that as the random variable or random experiment. So for each of the outcome, I'm writing the table. For zero heads, one head, two head, I'm writing the table. How many zero head are there? Only this. That's this one. This is double T. There is no head in this. That is 1/4 in that. How many one head? We have two possibilities like that. That is 2/4. And two heads, only one possibility, that is 1/4. This is probability distribution. So I have distributed the value for each outcome, possible outcomes. Okay. So if I plot this in the graph, something like this. Okay. So yeah, let me consider it as 2/4. This is 1/4. This is probability, and this is for number of head, the variable, random variable x. So for zero it is 1/4. Here it is, and for one it is 2/4. For 2 it is 1/4. So here in between this points, so in between these 2 points, right? How many values we can take? In between how many values we can have? One between 1 and 2 interval. Sorry.
I don't know, so like
So
from
there
one.
are infinite number of points. 1.0001, 1.002. There are multiple infinite points which are not covered, right? Infinite points not covered. Hence, it is a discrete random variable. Okay. So when you're writing a distribution for random variable, you should be having the possible outcome for each random variable, the random variable outcome, like 0 or 1 or 2, like that. That is called as the probability distribution. Okay.
Okay.
Yeah. Let's see the difference between these two: discrete random variable and continuous random variable. So the probability distribution in discrete random variable is called as probability mass function. Probability distribution of discrete random variable is called as probability mass function, PMF we call. The same probability distribution, if it is for continuous random variable, that is called as probability density function, PDF. This is the first difference. Then here, probability of any random outcome is more than 0, and the summation of probabilities will be equal to 1. Here you can check the sum of all these probabilities is equal to 1, right? And each probability of each outcome is more than 0, right? That is the feature of discrete random variable. Okay. Any doubt on this?
No, sir.
So here it is a function. The function value will be greater than or equal to 0. We'll see the continuous when we talk about it. And here the integration over the function will be equal to 1. So here will not, so it is countably infinite number of points in continuous random variable. We can't take all points and find out the probability like we did in discrete. It is not possible in continuous because there are countably infinite. So it is not countable first of all. It is infinite number of points we have in continuous random variable. For infinite number of points, we can't determine for each point what is the probability outcome or the probability value. So that's why we have a function. The function value will be more than 0, and when we integrate that function, uh, that is anti-derivative, then we'll get the total probability as 1. That is the difference here. Okay. Next, we have something called as expectation or mean. Mean means something like average value. Uh, right. Mean means average probability or something like that. Average probability or the common probability or the overall what is the average like that we are finding out. That is called as expectation. Expectation of discrete is determined by the summation of x into px, and the expectation of continuous is found by integrating x into f of x dx. And we have some standard distributions here like binomial distribution and Poisson's distribution. And we have here famous like exponential, normal, and uniform. We're seeing few of them. Okay? These are the famous distributions. So let me again tell you why we are studying these distributions. Okay, I'll tell you, but before that, anything doubt is there, you can ask me within this.
No, sir.
So let me just take a higher level understanding, okay, a higher level view of what we are talking about. So we have a normal distribution curve, something like this. Okay, so it is something like this curve might not be only fixed for some particular values. So what I can say is it is mostly like human, what I can say, human attentiveness. So it is similar. So for us also the same. So in the morning, we'll be a little bit dull. Okay, when we woke up. After a point, we'll be going to a peak uh, activeness, something like till evening. After evening, we'll be again getting back to the dullness, right? So this is fixable for human attentiveness. Then more than like next, for example, even students' excitement for learning. So for you also it's applicable. So you are in the beginning of the what is that preparation, right? Beginning of the preparation. You are having so day by day you'll be having that hike of this one interest to learn something new. So you will reach a saturation point sometime. So what we expect is it should be something like this. It should be stagnant. It should not come down. But generally, because of human tendencies, we'll see the downfall. But again, it may grow again from here, something like this, right? So why I'm saying talking about these distributions is so a particular type of what I can say movement, a particular type of flow of value, or particular type of what I can say is trend we call it as. That particular trend can be fixed for multiple types of problems, right? So there are some predefined trends that we will be talking about multiple different types of problems. So this we talked about normal distribution. Similarly, we have different trends. We try to set the trend. So we'll be seeing the problem. We'll be thinking which trend here is we are working about. So just we set that respect to distribution and we just solve it. That's the overview of it. Okay.
Okay.
I hope you got an overview of this. or I didn't made you confused?
No, sir, no, sir, it's clear.
Okay, fine. Okay, we'll talk about probability mass function. That is for discrete random variable probability mass function PMF. Let x be a discrete random variable such that probability of any value will be higher than will be equal to some value. It will not be equal to zero. I told it will be higher than zero first of all. Then the pi is said to be probability mass function, and it satisfies following conditions. First is the probability of any value will be greater than or equal to zero. Second thing, the summation of all the probability will be equal to 1. You can take an example. Coin tossed 3 times. So the sample space is equal to head head head, head head tail, head tail head, head tail tail, tail head head, tail head tail, tail tail head, tail tail tail. Now let me take a random variable x called as number of heads. So number of heads I'm just taking as a random variable. Then so it can be fixed for 4 heads, 5 heads, sorry, 4 toss, 5 toss, 6 toss. I'm not talking about more about toss here, but the random variable can take any number of outcomes like 3, 4, 5, 6. Okay, like that is the trend we are talking about. So the probability for each outcome we are now noting because we know that how many times it has tossed. So we can get either 0 head, 1 head, 2 head, or 3 head. Less than that number. So we can get if n is equal to 3, we'll get less than or equal to 0. The number of hits, right? Or greater than or equal to 0. And at max we can get n. That's what it is. So we have 0 head and 1 output, that is TTT, 1 head and 3 outputs, that is these things, single head. Then we have 2 heads and other 3 outputs, and we have 1 by 8 in 3 head. So if you see the trend of 0, 1, 2, that is 2 head toss, this is 1 by 4, this is 2 by 4, this is 1 by 4, correct? We written it in the previous discussion. So there is a trend if you see. So it will be just like something like this. This has been distributed to this two. Okay. Something like this. There is a trend following up. So you can, by seeing this, we can justify that each probability will be greater than or equal to 0. Sorry, greater than or equal to 0. Fine, greater than 0. And the summation of all the probabilities is equal to 1. Is it true? Is it true here? Is it a PMF?
Yes.
Okay. Next, we have one more called as cumulative distribution function for discrete itself. Okay. Distribution function. So we have let x be a discrete random variable, and it's a discrete distribution function, or we can say cumulative distribution function. It's called as CDF. Is f of x is equal to summation of pi, that is equal to p x less than or equal to, let's see for this. So if I want to write the CDF for the same thing, I'll be taking this example. For this example, I need to write the CDF for a T cumulative distribution function. So it will be something like, let me just show you. So if this is the case, then CDF will be something like this. So for x less than 0 or equal to 0, how many are there? 1 by 8. That's the answer. For x less than or equal to 1. So you should sum these two. Then you'll get the answer. That is 4 by 8. So it is a cumulation. Cumulation is, it is a collective probability for less than any number. So if it is less than 2, then it is cumulation of these three. That is 7 by 8. If it is less than or equal to 3, then the cumulation is 8 by 8. That is equal to 1. Right? So this is just a overview. You'll understand why we are talking about this when we see a problem. Okay. I hope not. I'm not making you doubtful.
It's clear, sir.
Okay, fine. Let's see some problems, then we'll understand this. We'll take a problem and let's solve it. Consider the following probability distribution. It is given as x and p of x. For 0 it is 0, 1 it is k, 2 it is 2k, 3 it is 2k, 4 it is 3k, 5 it is k square, 6 it is 2k square, 7 it is 7k square plus k. They were asking find, first is k, second is p x less than 6, p x greater than or equal to 6. Then p x lies between this one, and fourth one is probability distribution function. Fifth is if probability x is less than some c value which is greater than 1 by 2, find the c value. And sixth one is find 1.5 less than x 1.5. Yeah. So let's find out one by one. Just understand this. So first one is k, we need to find out, right? How to find out k? Do you have any idea here?
take the sum and equate it to 1.
Yes. So we know that summation of probability will be equal to 1. That is sum of 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k will be equal to 1. So we'll use this and we get that 10k square plus 9k minus, so 9k is equal to 1. Then 10k square plus 9k minus 1 is equal to 0. This is the quadratic equation. So let me take the roots, that is 10 ones are 10k minus k minus 1 is equal to 0. So here 10k is common, remaining is k plus 1, and here it is minus 1, k plus 1 it is equal to 0. So let me take common ones and the remaining ones. So the answer is k is equal to minus 1 or k is equal to 1 by 10. Probability will never be a negative value, so the answer is 1 by 10, k value. Okay.
Yes, sir.
Next, second problem. We have to find out probability less than 6. Okay, that is the cumulative function. It is cumulative they are talking about. So probability of function less than 6. So I can also write this as 1 minus probability of function x greater than 6. Is it true? Because the total of the value will be always 1. Here in cumulative also, the final value will be 1 for the total probability, the complete values, whatever is possible. So can I write this as 1 minus the value of x greater than or equal to 6?
Yes.
So it is easy to solve. In other way also you can solve, like by taking the sum of 1, 2, 3, 4, 5. That will take some time. That's why I'm just shifting the things. So this is p of 6 plus p of 7. That is 1 minus, if you put k value here in 6, it is 2 into 1 by 10 square, that is 1 by 100, correct? This is 7 into 7 by 100 plus 1 by 10. Okay. If you solve this, you'll get 0.19, that is equal to 0.8 is the answer. Or if you do in the way like adding these five values, you still get the same answer. You can just take it out. It should be the same. Okay.
Yes, sir.
That is this value, and we have also found out this, right? That is 0.19. Okay.
Yes, sir.
Now we will be finding out third one, that is cumulative for between 0 to 5. So this is they are asking about cumulative function. Okay, between 0 to 5. Let's do this. Third one, it is a CDF. So it is f of x is equal to, so it is 0 for x less than 0, and k value, that is zero point 0.1 for x less than or equal to 1 is 2k, that is so it is a cumulative 0.2 plus zero point 0.1 it is, right? That is x less than or equal to 2. Next, again 2k, that is 0.2 plus zero point 0.2 plus zero point 0.1. I'm just writing in this way so that you can understand this. No need to write like this. Ck, that is 0.3 plus 0.2 plus 0.2 plus 0.1 plus 0, that is less than or equal to 4. You need to find till less than or equal to 5, right? Yeah. K square, that is just add it. K square is 0.01, 0.01 plus zero point 0.3, like this, these things. That will be for less than 5. That is point, it is 81. This is 0.8. This is 0.5. This is 0.3. This is 0.1. This is 0. This is the value in between this distribution. Okay. Or you can let me write this including fourth one also. The distribution function they are asking, right? That is also a cumulative distribution function. Let's continue this. That is x less than or equal to 6, that is 0.83. It is 1 for x less than or equal to 7. It covers both fourth and fifth question. Fifth question answer is, sorry, fourth question, sorry. The answer is for fifth, what is the answer? That is the answer here. Point less than, right? So you can't take this less than or equal to, you should take this value. That will be the answer for this. 0.8. Okay? Less than they have told. They are talking about like x lies between 0 to 5, not equal to. So you should take one value below that. So that will be the value for this question. And next one, distribution is this, the complete thing will be the distribution. Okay?
Yes, sir.
Next, if C value is something like C, which is greater than 1 by 2, find the value of C. Okay, greater than. So you should be finding out the smallest value which is having highest than 0.5, which is the value in this distribution having a, a value more than 0.5, which is smallest. So you have multiple values here, which is the smallest among them.
4.
Yeah, 4. That is 0.8 is the greater than 0.5, right? 4 is the answer. For that, C value is 4. Okay, understood?
Yes, sir.
Next, one last question. That is, this is, what is it? Okay, 1 by, so the distribution between 0.5, 1.5 and 4.5, which is x greater than 2. So let's solve that. It is conditional probability here, okay? It's actually conditional probability. So it is something like P of A given B is equal to P of A intersection B by P of B. That is in the term. It is the conditional probability. This one. So they are asking what is the probability distribution value such that it is given that the x value is more than 2. That is the conditional probability. Okay. So we'll be using this formula of conditional probability. It will be equal to probability of 1.5 in between 0.4, 1.5 and 4.5. Given that x greater than 0, this is the question. So it will become like probability of 1.5 between 4.5 intersection probability of x value greater than 2 by probability of x value greater than 2. Okay. Then, so between 1.5 and 4.5, the probabilities are 2, 3, 4, right? The values of x possible. Intersection greater than 2 is 3, 4, 5, 6, 7. Below, this I can write as 1 minus probability of x less than or equal to 2. So what is the common thing in between these two in the numerator? 3 and 4. That is probability of 3 plus probability of 4 by, this is 1 minus probability of 0 plus probability of 1 plus probability of 2. Yes. So this is probability of 3 is how much? Here.
0.2.
3. Yeah, 0.2. 4 is 3 into, yeah, 0.3, right? Divided by 1 minus 0 is 0, I guess. Then I had k, I guess. K plus 2k. Okay. K is 0.1, 2k is 0.2. So the answer is 0.5 by this is 0.3 is 0.7. That is the answer. That is 5 by 7. Okay.
Yes, sir.
Understood or any doubt is there?
No, sir. No, sir. It's clear.
Okay. Let me ask some questions and we can just discuss about this. Okay. So there is a notes I got. I'm not sharing to you, but it is actually for your IIT jam. This notes is a bit horrible. Okay, you can't read this. That's why I just taking the just taking the topics which are there just to so see that what are topics are there. Just I'm seeing that notes, but don't follow any other notes. The representation all are very much horrible. You will not be understanding that. Okay. We don't need to write this for exam, right? That's why I'm saying.
Okay.
Just take some simple representation. Anyhow, you don't need to write the descriptive answers. Okay. So let's first search for some questions. Okay, take this problem. You do this. I'll be back in a minute. Okay,
Okay, sir.
and I'll ask you after coming. Yeah, Ananya, how much you did?
I got the answer, sir.
Okay.
For the first question, is it all the value?
Yeah, what and all values you can take?
Okay.
Like you can say like from what values to what values it is taking, or something like if you tell me all the values, it is very good. If
Okay.
X values are there in the CDF, no, that is the answer. CMF, PMF, sir.
For the second question, the answer is point 0.5. Summation of first three
Yeah,
values.
that is correct. Point 5 is correct. Next.
Point 0.4.
Hmm. Yes.
1
This
by
is
5.
what is the answer? This one? What was the last one?
1 by 5.
No, that is wrong. You just do it again. For this, the answer is the all the possible values like point 0.2, point 0.4, point 0.5, point 0.8, and 1. 1 by 5 you told, no?
Yes, sir.
Yeah, correct. It is, sorry. It is point 0.2. Correct.
Okay, sir.
Next question. Okay. Next question. I hope you are writing notes. Do you want my notes? I don't think it is required, but still I can
Yes,
share this.
I'm taking notes, sir. I'm
Okay.
taking notes.
So I can send you after the course, okay? Like at least for the chapter wise, for just for reference, my lecture notes.
Okay,
Okay.
sir.
From here you are okay, fine. This is I. I roll two dice, and observe two numbers, X and Y. Find Rx and Ry. The range of this is range of X, range of Y, and the PMFs of X and Y. Next, find probability of X being equal to 2 and Y is equal to 6. C, find probability of X is greater than 3 given Y is equal to 2. D, let Z is equal to a new random variable, that is X plus Y. Find the range of Z. Find the range and PMF of Z. Next, E, find the probability of X is equal to 4 given that Z is equal to 8. Just try out. Anyhow, we will solve it.
So can you solve this one?
Okay, that's all. I thought like it is a bit different. Okay, let me solve this. First question is they are asking range of x and range of y. Both will be same. It is 1 to 6. A range of x will be equal to range of y, that is equal to the value from 1 to 6 it is. Correct?
Yes.
Next. We are assuming that a fair dice is ruled. That's why the probability mass function PMF is same for both. Okay, you can say P of x and it is also equal to P of y of k. It is equal to 1 by 6. We are writing PMF, not CDF. It is probability mass function, not probability distribution function. So it is just like a table, or you can write like this also. 1 by 6 for k is equal to 1 to 6. And it is 0 otherwise. This is one way of writing PMF, or you can write the table which we seen here. This one. Yeah. This is not CDF, this is PMF. Okay. Next. That is the first question answer. Second question. Find the x is equal to 2 and y is equal to 6. So P of x is equal to 2, comma y is equal to 6. This is a independent event, right? Getting 2 in x is not dependent on getting 6 in y. Is it dependent or independent?
Independent.
Independent. That's why there is no common things. That's why I'm just multiplying the possibilities. If you remember the multiplication rule, right? Somewhere is seen it. Multiplication rule.
Yes, sir, I know it.
Yeah,
Probability
yeah.
of A into probability of B.
Yeah. So that is the case. So it is what? How much is the chances of getting 2? It is 1 by 6. How much is the chance of getting 6? That is also 1 by 6. That is answer is 1 by 36 is the answer. For second. Third one. Find the value of x greater than 3 such given that y is equal to 2. So this is B, this is C. Probability of x being greater than 3 given that y is equal to 2. It is mm, so it is the common thing between, okay, 1 second. So it is actually equal to probability of x being greater than 3. The y value doesn't matter here, right? Does it matter here? Y value being 2, will it influence x value?
No, sir.
It doesn't. That's why it is directly P of x greater than 3. That is equal to P of being 4, P of being 5, plus P of being 6. That is equal to 1 by 6 plus 1 by 6 plus 1 by 6. That is equal to 1 by 2. 3 by 6. That is 1 by 2. That is the C. D question. Z is a new random variable. So it is the sum of x plus 5. So Z will be ranging from first 1 plus 2, 1 plus 1, 2 to the max it can take is 12. Right, 2 to 12 it is. And we need to find out the PMF of it. Correct. Okay. This is clear. 2 to 12. the range of Z, random variable Z.
Sir,
1
yes.
plus 1. Yeah, next like that. So we need to find out the PMF. So PZ of 2. So let me write that. 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6, 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6, 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So sum I'm taking now: 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. Okay. There is a trend if you see. Okay. Now, how much 2 we get? How much 2 will get here?
1.
1. That is 1 by 36. Okay. Next, how much 3 will get? 2, I
2.
guess. 2 by 36. That is 1 by 8. 18. Next, 4.
3.
It is, yeah, 1 by, sorry, 3 by 36. That is 1 by 12. Like that. Directly we can write the PMF, right? Okay. This is itself is fine. You need to find out others also. Just write these values, that will be fine for PMS. It is not CDF. 5. How much 5? It is, I guess, 4 by 36, right? That is the trend here. 1 by 9. P of 6, sorry, PZ, it is where here everywhere. Of 6. It is 5 by 36. No change. PZ by 7. That is 6 by 36. 1 by 6. Next. PZ of 8. 7 by 36. PZ of 9. 4 by 36. That is 1 by 9. PZ of 10. That is, what is this number I written? Okay. 9 is how much? Okay, 4 by 36. Okay, now 3 by 36. It is ready. So this is a kind of normal distribution, right? It raised, again it is coming back. Correct? Kind of. Like this is discrete. I know that. But if it isn't continuous, it is something like normal distribution. That's what I'm saying, like the trend. Next, PZ of 11. 2 it is there. That is 1 by 18 again. Lastly, PZ of 12. Only 1 is there, 1 by 36. That's the PMF. Clear? Next. Yeah, try to do this if possible. Try to do this last one. Else I'll do. I hope I'm audible.
Yes, sir, yes.
Yeah, and even my screen is visible. I'll do the last one.
Okay. Sir,
Yeah.
is it 1 by 7?
No, it is 1 by 5. So if x is 4, y will be also 4, right? To make z as 8.
Yes, sir.
So your question is x is equal to 4 such that z is equal to 8. Means if x is 4, y will be also be 4 to make z is equal to 8. So let's find out. So it is 1 by 6 into 1 by 6. How much 8 we have? 7 by 6, right? Huh? How much 8 we have? Okay. Yeah, I think your answer is correct. You told 7 by 36, right? Okay. That is 1 by 7. You told 1 by 7, no? I guess so. Right? Hello?
Okay, sir.
Yeah, it is correct, right? 1 by 7 is correct. Yeah. Next question. One last problem we'll do. Okay. Mm, simple question. We saw this. Just take this as a homework. Okay.
Okay, sir.
Take a screenshot or something and take it to the homework. Yeah. Taken?
Yes, sir. Yes.